Hi guys, this video is on AP Calculus AB 2024 FRQ 6 solution. So let's solve. The functions f and g are defined by fx is equal to x square plus 2 and gx is equal to x square minus 2x. Let R be the region bounded by the graph fg from x equals 0 to x equals 2, which is obviously this, right? But do not evaluate an integral expression that gives the area. So we know that the area bounded between the two curves is given by the integral from the lower bound to the upper bound of the upper function minus the lower function integral. So the bounds are clearly 0 to 2. The upper function is obviously x square plus 2, and the lower function is of course gx, which is x square minus 2x and dx over here, which is equal to 0 to 2 of x square plus 2x minus x square plus 2 minus x square plus 2x if we just distribute the negative. And finally x square minus x square is gone, so I'm just left with 2 plus 2x. So 0 to 2 of 2 plus 2x dx. Although they're asking an integral expression that gives the value of do not evaluate, I'm not sure. I think if you, I mean, it's pretty much intuitive. Even if you leave the answer here, that you should get full credit. But yeah, this was like very straightforward, so I just went ahead and simplified. Okay, so that's about it. B asks about, let S be the region bounded by the graph G and the x-axis from 2 to 5, which is obviously this. Now S is the base of a solid, and for this solid, at each x the cross section is perpendicular to the x-axis, a rectangle with height equal to half its base in the region S. So what is the volume of the solid? Show work that leads to your answer. This is just not just an expression, we need to get the final answer. All right, so wherever we draw the base of a rectangle, maybe somewhere over here, we know that the area, the volume given by the rectangle will be the bounds, which are clearly from 2 to 5. And since this is perpendicular to the x-axis, the integral is also with respect to x. That's why, you know, the bounds are of x. And what is the area of the rectangle? Obviously, its length, which is basically this. Let's denote it with L, times the height, which is something which we do not know at the moment. And this, when integrated, will give us the total volume. Now we know that this L is nothing but the height of the function, right? This is the height of the function because clearly this is the, I mean, it's pretty much intuitive. So G, what is G, by the way? We know G, right? It's x square minus 2x. So I know that L is x square minus 2x. And it's already given that the height is equal to half its base. And the base is nothing but the L, right? That is the base. So can I say that h is L over 2? Because that's what they are saying, right? Rectangle with height equal to half its base, dx, and the integration is from 2 to 5. All right, so this comes out as 1 over 2 is taken out. I want to integrate from 2 to 5, L square dx. And what is L? X square minus 2x. So all we need to do is sub in and find this out. So x square minus 2x whole square dx. So I'm just going to open this up. It's going to look like, I'm going to use a minus b whole square identity, which is first term square plus second term square minus 2 times first term times second term, which is 4x cube dx from 2 to 5. Right, unfortunately this is no calculator, so let me try to make some space over here. All right, so what is the integral of x raised to 4 is x raised to 5 over 5, and what is the integral of 4x square is x cube over 3, and this is x raised to 4 over 4. The bounds are from 2 to 5. So that's gonna look like, boy, the numbers are big. So we need to make sure. Okay, so I think I'm gonna need some more space here. So let me just pull this entire thing onto the next slide and work here. Okay, so this will be half of the upper bound and half is just taken outside the entire thing. The upper bound is 5, so 5 raised to 5 over 5. By the way, this 4 and 4 is gone. 4/3 of 5 cube and 5 raised to 4 over here. Okay, excellent. Uh, let's place it like this. Minus the lower bound, which is 2 raised to 5 over 5, plus 4 over 3 times 2 cube minus 2 raised to 4. Okay, excellent. 5 raised to 5 over 5 is 5 raised to 4. 5 cube is, I believe, 125. So 4 over 3 times 125 minus 5 raised to, whoa, we are in luck. These two things are gone if I'm not wrong. All right, excellent. So if this happens, then what about the next one, guys? The other one will also, I think, can also be simplified, something like this. So that's going to look like 2 raised to 5, 2, 4, 8, 16, 32. 32 over 5 plus 2 cube is 8. 8 times 4 is 32. So that's 32 over 3. 2, 4, 8, 16. So that's 16 over here. So that will be 1/2 of 125 times 4 is, I think, 500. 500 over 3 minus 32 over 5 minus 32 over 3. Well, be careful. Plus 16, because double negatives will become positive over here. I think we can take these two together. So, oh my God, let's add another slide. So let me copy this entire thing and paste it here. Okay. Right, so I'm gonna club these two things, and what is 500 minus 32? I think that's 468 divided by 3 minus 32 over 5 plus 16. So that's going to look like half of, this is going to be 15 over here. I think it is okay to leave it here. Yeah, it's totally fine to leave it here. Although we can just simplify this as well, because that's easy, right? 16 times 5 is 80. 80 minus 30 is 50. 50 minus 2 is 48. So that's 468 over 3 minus 48 over 5. And I think this entire thing can be divided with 2 so that we don't have this. So that's 2, 3, 4. That's interesting. And this is 24 over 5. Right. So that is the final answer which we have over here for the volume. All right, the last one which you have is right, but do not evaluate. Oh, thank God. An integral expression that gives the volume of the solid generated when the S described in B is rotated about the horizontal line y is equal to 20. All right, okay, y is equal to 20 somewhere over here. And remember that this line is parallel to the x-axis. So the integral will be with respect to dx. Clearly this is a washer method, because the moment you will draw the two discs, the first one will be this one. And the second one is going to be this one, because clearly we just need this portion, right? So that's clearly a washer. Okay. So what is the formula, guys? The formula says that pi times integral of, the bounds are from 2 to 5, upper radius square minus lower radius square dx. We just need to give them an expression. So this is 2 to 5 of, what is the upper radius? Upper radius is this one over here. Let me switch the colors. Okay, this one. What is this? I think that's just 20, because this is y is equal to 20. So isn't this height 20? So that's going to be 20 square minus small r. And small r is only this one, right? And is only this one, which is surely 20 minus something. And that something is nothing but the y value of the function gx, which is just gx, right? Just gx. So 20 minus g, that's going to be the function, that's going to be the small r. So 20 minus g, 20 minus g, where g is, what was g? X square minus 2x. So x square, make sure to put this in parentheses, minus 2x, and this entire thing is being squared, and this entire thing once again is in the parentheses, dx. And I think we can leave the answer here. If you want, you can just simplify it a little further by distributing the negative sign inside. So finally, the answer is pi integral from 2 to 5 of, let's put a bracket here, 20 square minus 20 minus x square plus 2x square, bracket close, dx. So that is the required volume using a washer method of this function, of this area rather, about y equal to 20. Right, I hope this makes sense. Any questions, please post it down in the comment section, and I will see you in the next video. Bye-bye.